Here's problem 3518. An aquarium contains a 5 centimeter layer of water, index of refraction 1.333, floating on top of carbon tetrachloride 1.461. If the angle of incidence into the water from the carbon tetrachloride is 20 degrees, what is the angle of refraction into the air? Well, this actually is just exactly the reverse problem of number 17 that we just did, and so we should expect that everything will be reversed as far as our answer. So we should expect a 30-degree angle into the air. Let's see how this works out. We're going from carbon tetrachloride, 1.461, into water, 1.333, into air, 1.0, and we have an angle of incidence of 20 degrees from the carbon tetrachloride into the water. So as it's going from a higher index to a lower index, it's going to refract a little bit away. And then we're going from the water into the air, and again it's going to refract a little bit away. So we have theta 1, we have theta 2. Theta 2 is going to be the same for our angle of refraction into the water as it is our angle of incidence from the water into the air, and then we will have theta 3 as well. Snell's law applies, so we have n1 sine theta 1 equals n2 sine theta 2, and for this matter, since our internal angles are equal inside the water there, this will also be equal to n3 sine theta 3. So in this case, we can cut out the middleman, and we have that n1 sine theta 1 equals n3 sine theta 3, and we want to find theta 3. So theta 3 is going to equal the inverse sine of index 1 over index 3 sine theta 1. And that's going to be the inverse sine. Index 1 is the carbon tetrachloride, 1.461. Index 3 is air. And our incident angle from the carbon tetrachloride into the water is 20 degrees. So what is that? .98, so we say 30 degrees, 30.0 degrees into the air. So our angle of refraction into the air is 30 degrees. That's our answer. And in this particular case, the fact that the water layer was 5 centimeters thick and the fact that we even had water in the middle didn't really matter. We could have had any substance in the middle there where Snell's law is applying, and we'd still have the same result, 30 degrees into the air.